BATCH32, third year ECE, National Engineering College.
Hello all, I am Shakti Lakshma from third year
I'm Samarashi, third year ECE student, National Engineering College.
and my mentor is Dr. K. Subramanian, Assistant Senior Grade Professor of EC Department. Let's get into the slide. And our main objective of our project, there are three main objectives. First is to analyze and enhance an assistant toy car for providing the functionality and the performance. To transform a remote control car into an autonomous robot it's capable of intelligence and navigation using sensor for light and obstacle detection. To develop a smart surveillance system that integrates real-time monitoring, optimized path planning, and adaptive decision-making based on the environmental data. And our next slide is about abstract. Autonomous surveillance platform, a commercially available RC stand car, is transforming into a mobile surveillance robot equipped with customer PC and real-time video capability. Here, we integrate the Jetson Nano as a microcontroller handles intelligent processing, enable adaptive decision making, and autonomous navigation in dynamic environments. Obstacle detection and mobility. Built-in obstacle detection ensures a safety movement, allowing the robot to operate continuously and effectively across varied terrains for responsive and secure monitoring. Cost-effective and scalability design. By leveraging the consumer-grade components, the system remains affordable and easily scalable, making it suitable for industrial and emergency response and applications. Introduction. Traditional surveillance systems are limited by fixed camera positions, while basic RC platform lack the intelligence for dynamic monitoring. This project transforms a low cost of RC stunt car into an autonomous surveillance robot by integrating a Jetson Nano microcontroller, ultrasonic sensor for obstacle detection, and real-time for video camera, originally powered by a 3.7 volt of lithium-ion battery and controlled via custom PCB with transmitter or upgraded to navigate complex environment safely and efficiently. The result is a mobile, cost efficient with potential of future enhancement like objective recognition and autonomous alert. This is the block diagram of the existing product. As we chose RC stand car, here it has the front wheel. Both the front wheels are connected, are powered by the transmitter, and here it is a switch which act as a toggle switch, which act as a power supply is from the lithium battery. This is the existing system block diagram. Okay, here it is the gap identified. Gap. The assistance cars are limited to remote control, okay, with no intelligence for autonomous movement. Cannot adapt to a dynamic environment or respond to changing conditions without human interventions. No capability for real-time surveillance, obstacle avoidance, and environmental interaction. And let's go to the next slide. These are the components that are present in our existing product, okay. The main 7 components, okay, aside the wheels and those chasers and all, these are the 7 main components. First is DC gear motor and for lithium battery and for PCB of 01GY2060R and transmitter which is attached with the PC, and for DC gear motor, and 7th was ceramic capacitor, and this is the PCB layout of our model. And we took the sample data sheets that are components present in our forward engineering product, that RC stand car, and it's a data sheet for the we only filterize the features. It's for DC gear motor, and it's for the controller, and here it is for the H bridge, and it's for the lithium battery. And next slide will be handled by Shakti Lakshma.
Hello all, I am Shakti Lakshma from 3rd year ECE. Let me explain role of the individual components. TXM 8D423TS X166589 IC. So the function of the IC is it receives RF signals from the remote control and it decodes these signals into the control commands. So let us look into the properties. Operating frequency 2.4 GHz ISM band and its bandwidth is 83.5 megahertz. That the low power consumption efficient for battery operated devices. So let us look into the DC gear motors. The function of the DC gear motor is it converts the electrical energy into the mechanical rotational motion, providing the necessary torque to drive the wheels of the RC car. Also, the properties are compact and efficient, reversible rotation, high torque at low speed. So for gear reduction, we are using this DC gear motor. Then suitable for small robotic and RC applications. Minimal applications can be used from these gear motors. Reversible rotation. For the reversal function of the motor, function of the kit, direction of rotation can be easily controlled via H-bridge drivers. Then the next is the control system PCB 01GY2060R. The function of the PCB is it acts as the control, central control hub handling RF signal processing, motor control via H-bridge drivers, and power regulation for all the electronic components. So it acts as the central functional unit, and the components which are connected are interfaces with the RF receiver TXM8423TS X166589 IC, motor drivers, DC gear motors, battery, and supporting electronic components. And then next we can look into the proposed model, upgrading the RC car's basic control with the Jetson Nano microcontroller, which enables the advanced real-time processing of sensor data, decision making, and autonomous navigation for intelligent operation. So by integrating these ultrasonic sensors, the system achieves reliable obstacle detection, avoidance, allowing safe traversal of complex and dynamic indoor environments without human intervention. A mounted HD camera module which enables the live video capturing and wireless transmission, supporting continuous remote monitoring and responsive surveillance. Leveraging computational power of Jetson Nano, the system is capable of edge AI tasks and real-time video analytics, paving way for advanced features like object detection, smart patrol routines, and automated alerts. So this is the proposed flow model. So initially start, then power supply is being initialized, battery voltage to Jetson Nano regulated 5 volt power supply to ultrasonic sensor. Then the Jetson Nano, it's getting boost up. Jetson Nano process feedback. Ultrasonic sensor detects obstacles, and then it is given to the L2989 motor driver, which controls the DC motors, environmental feedback and adjustment. Then finally the robot moves accordingly. Proposed block diagram. Jetson Nano, it acts as the control processing unit, image processing, and the trigger signal is given to the ultrasonic sensor, obstacle detection. Video is fed via the camera, environmental feedback, obstacle detection. So then everything is applied via the power supply. We have left DC motor and right DC motor for the physical movement. Finally, the output GPIO output can be initiated through the motor driver. So now let us look into the simulation model of our project. This is how the connection is used based on the kits we have implemented in the OP module. And this is our product. So this is the image view of our project, which have the Jetson Nano and camera module interfaced with it. So let us look into the survey result. These are the results which have taken by us. These are the sample output taken and the conclusion and future scope. The developed robotic system showed reliable line tracking, obstacle avoidance, and real-time surveillance using Jetson Nano and sensor integration. With stable performance and minimal turning, it offers strong potential for future upgrades like AI-based object detection, smart navigation, and use in applications such as smart cities, education, and